In the previous video, we talked about geometric predicates, and the basic predicate that we saw is the sidedness test. And as I mentioned, there are two versions of this. One is that you can just decide whether a point is above, below, or on a line, and the other one is orientation test, which is this one. So this is technically known as an orientation test, which given 2 points P1, P2, and P3 decides whether you make a right turn or a left turn as a move from point 1 to 2 to 3. Okay. If you remember in the previous video, I mentioned that you typically put these formulas in only a very small number of functions, and then you can build on top of them. We're going to see an example of it in this video. So let's say you have a line L and you have a line segment S given by 2 points. So the line segment is given by a pair of points Q1 and Q2. So Q1 and Q2 is a pair that specifies a line segment S. We would like to know if the line L1 intersects the line segment given by 2 points Q1 and Q2. How do we do this? Just pause the video for a moment and think about this. To give you a hint, I'll draw these two other cases. Okay, if you have paused the video and then, so let's see, also hopefully I'll pause the video so I can talk about the solution. If you look at this picture here, you see that in these two scenarios, the line segments don't intersect. The line segments and line don't intersect. So here the line segment is above, here the line segment is below. So the only way the two line segments can intersect, so the line segment can intersect the line, is that if one of the points of the line segment is below, the other point is above. Okay, so that means with the sidedness test that we implemented in the previous video, we could just decide this. And then the pseudocode could look something like this. If Q1 is on the line or Q2 is on the line, then we have the tangency issue scenario, which corresponds to this case. Just as, you know. Otherwise, then we don't have tangency, so we have only two cases. If Q1 is below and Q2 is below, then we say that the line segment is below the line. If Q1 is above and Q2 is above, then we say above the line, but otherwise they're intersecting. Note that there is no math here, so no math. So where is all the math? All the math is inside all these functions that you call. Below, like these, this is all this sidedness test. You call sidedness test multiple times, which means that the math is now abstracted away. It doesn't matter what is the representation of point Q1, what is the representation of line L1. As long as you can decide whether the point is above or below the line, you could run this pseudocode, or you can run this code. That's actually why we need geometric predicates. The main math part of the computational geometry has been hidden away inside these predicates. And all we're doing here is using geometric properties of lines and segments to decide whether a line segment intersects a line. That's basically computational geometry. So let's move on to a slightly more complicated example, and that is two line segments. So I have two line segments given by points P1 and P2, and another one given by points Q1 and Q2. I want to know whether they intersect or not. Again, try to pause the video and think about this for a minute. Hopefully you could figure it out, but basically I'm going to give you the main idea, but then we're going to look at the special cases given by tangency. So the main idea is that you could have an intersection between two line segments if, let's say we don't have intersection. So in this case, the two line segments don't intersect, which means that, and as you can see in the picture, if I drew the line L1 through P1 and P2, the other line segment is completely below. Okay, you may think that that's enough, but if the line segment was like this, then they would still be non-intersecting. But in that case, the line through this line segment doesn't intersect the other line segment. So in particular, for two line segments to not intersect, you should have this property that if you draw the line L1 through one of them, if the other one is below, then they don't intersect. Then you draw the other one. And again, if the other line segment is above or below the line L2, then they don't intersect. So the only way two line segments can intersect is that if you draw the line through any of them, the other one intersects that line. So for example, like this. So basically the pseudocode is something like this. If L1 intersects Q and L2 intersects P, then the intersection is true, otherwise they're non-intersecting. Okay. So what is important to have here? So we need a predicate that given a line L1 and given a point, a line segment Q, can decide whether those two things intersect. Well, obviously that was the previous video, the previous slide. So we can use this code to build the next code. Of course, the only issue here is that how you do the representation. In other words, if you have, let me go back here. So here, if your L1 is represented by y equals ax plus b, and a point is represented by xy, by its x and y coordinates, then here you have a slightly different problem, right? So here you have the points P1 and P2, which means that you don't have the specification of the line. Okay? So you will need a predicate that can decide whether a point is below a line given by 2 points. And that's essentially the orientation test that we talked about. Okay. So this could get a little bit complicated, and in particular, let me make another comment that you might think that if you have the points P1 and P2, you can easily calculate the line that goes through them, which is correct. But what you should also pay attention is that any floating point operation that you do will cause errors. So since floating point operations are not exact, calculating the line that goes through 2 points will have some error in them. And we're going to talk about these issues in the later videos. So let's talk about tangency issues. We have ignored tangency. The tangency creates lots of interesting conditions when it comes to two line segments. So you can have this kind of tangency. You could have this kind of tangency, which is not, which we don't consider a special case. In this case, if you draw the line through, say, the first line segment, the other line segment is tangent to it. In this case, even though that's a special case, we don't have a name for it because we just think of them as non-intersecting. And the final special case is this thing which is overlapping. So two line segments overlap. Once again, this is if the two line segments are along the same line, but they're like this, then they are non-intersecting. This is not considered a special case. But your code should be able to capture this, right? Because in this case, if you draw the line through any of them, the other one is on it. So capturing these special cases with two line segments is a little bit complicated. So that's why I didn't write it in my code here. Otherwise, my pseudocode would have looked very complicated and scary.